Using the general properties of reaction enthalpy. This becomes very important when you're looking at reactions that occur in 2 or more different steps, and you have to sum the enthalpy for each individual step to work out the enthalpy for the overall reaction. So the basic idea of, see this reaction right here, this delta H, the enthalpy change for this reaction only applies to this reaction exactly as written. So if we reverse the direction of this reaction, so if instead of going from products to reactants, if instead of going from reactants to products, it's written the other way around. So what is the products is written here? In this case, gaseous water becomes the reactant in another equation. Then we'd have to reverse the sign of delta H. So if we reverse the direction of equation, you're going to have to change the sign of delta H. Okay. If you have to multiply or divide by an integer to get from this equation as written to the one you're being asked about, then you'll do the same to delta H. So if you multiply or divide by integer, then you're going to multiply or divide delta H by the same integer. Okay, so basically it's a game of spot the difference. Okay, so if we look at this first line here, so 2H2O gas goes to 2H2O liquid, we can see the direction's been reversed, because here liquid water is the reactant and gaseous water is the product, and here gaseous water is the reactant and liquid water is the product. So we're going to have to get delta H, we're going to have to times by -1, okay, and to reverse the sign. And what else are we going to have to do? I can see the stoichiometry is doubled as well. So it's 1 mole of liquid water to 1 mole of gaseous water in the reaction as written, and here it's 2 to 2. So I'm also going to have to multiply this by 2. So I'm going to have to take 44 kilojoules, change the sign, so it's -44 kilojoules, and then times by 2, so my overall reaction is going to be -88 kilojoules. I could type. Oh my God, I can't type today. Okay, so then let's look at the second one. So here we can see that the reaction is going in the same direction as in the original, from liquid water to gaseous water, but it's been multiplied by an integer. So delta H is just going to be 5 times 44 kilojoules, which is going to be 220 kilojoules. So if I want, I can be very obvious and put that plus on the front there. And then finally, I'm going from gaseous water to liquid water, which is the exact opposite direction of the reaction as written. So delta H is -44 kilojoules. So just change the direction, change the sign. All right, so hopefully that is helpful for you. So sometimes just one thing's happening at a time, and sometimes 2 or more different things are happening at the same time to the equation. So you've got to do the same thing to delta H for the enthalpy change.